Welcome to Science Access. In today's class, we'll be continuing on our indices series, Law of Indices, and we'll be taking question and answer on the Law of Indices. If you know you have not watched my part 1 and my part 2 of the Law of Indices, where I introduce the law and how to apply it, please go and watch it so that you know the laws that I'm applying to solve each question. All right, please subscribe and put on the notification button so that you get notified whenever I post a new video. All right, let's start with question number 1. B raised to the power of 4 times b raised to the power of 3 times b raised to the power of 5 all over b. This place is actually b times b raised to the power of 6. Now remember, if you have just b here, what you need to do is just put one. There's an invisible one there showing that b is just 1. So we'll add our invisible one here. All right. Now, because no question will put the invisible one for you, so you have to add it yourself. As usual, once you have multiplication sign in this place, what do? You pick one of the base. Remember, this is the base, and these are the index or the powers. So since the base are the same thing, you just pick one. Since it's actually multiplication in the numerator, you add the powers. So I'll pick one of these base, then I'll add this power. 4, 3, and 5. So base here be 4 plus 3 plus 5 all over. All right. I'll do the same for the denominator. I'll pick one base and I'll add the powers. Here we have 1 and here we have 6. So 1 plus 6. So if I add this together, I'll have b raised to the power 12. And if I add 1 plus 6, I have b raised to the power 7. Now, note that this sign is actually division sign. And in the law of indices, division sign is actually minus. So you subtract the power. You have b raised to the power 12 divided by b raised to the power 7. So I'll pick one, but I'll subtract the power. So that's what I did in this place. That's what I did in this place. I picked one and I now put 12 minus 7. Remember, because of the division sign, I have to subtract. If it's multiplication sign, I'll have to add, just the way I did in the numerator and the denominator. So please take note. B, I pick one of the B. Then because of 12, because of the division sign, I'll now subtract, put the subtraction sign, then 12 minus 7. And 12 minus 7 is actually b raised to the power what? 5. 12 minus 7 is 5. So we have b raised to the power 5 as our answer. The next question is also very easy. We have 5 raised to the power x minus 1 times 5 raised to the power 1 minus x. What do? Remember, both bases are the same. So I'll pick one, put x minus 1 here, plus x and 1 minus x. The plus is because this place is actually multiplication. So let's add this place. I have 5x minus 1 plus 1 minus x. In this power, I'll actually have to add or collect like terms before I add anyway. So let's collect like terms. We now have this x is here. I'll take this minus x to this place. Now this minus 1 is here. I'll now plus what? 1 is here. So x minus x is actually 0. 1 minus 1 plus 1, you can use your calculator, is also 0. So we have here 0, here 0. 0 minus 0 is actually 0. So we have 5 raised to the power 0. Remember the law of indices, as I taught in my previous video, anything raised to the power 0 is actually 1. So even 1 million raised to the power 0 is 1. So let's take question number 3. Question number 3, we have 3 brackets. This whole stuff. 3a raised to the power 5 all over 10a raised to the power 6 and all that. Close your bracket, raised to the power 0 times 3x raised to the power minus 1. Now, this question is very easy. How do I solve it? Anything raised to the power 0, even if you put all the figure in the whole board, raised to the power 0 is actually 1. So everything here is actually 1. So now I have 3 times 1 times, now remember there is 3 here. So 3 times, this is x raised to the power minus 1. Another law of indices says that if you raise x raised to the power minus 1 is the same thing as 1 all over x. So I now have 3 times 1 all over x. Remember, this 1 all over x is the same thing as x raised to the power minus 1. So let's solve. 3 times 1 times 3 times 1. 3 times 3 is actually 9, which we have here. That's 3 times 3. 3 times 1 is 3. 3 times 1 is 3. So that's what we have here. Then 3 all over x. We can decide to put 1 here. 3 times 3 is 9, and 1 times x is x. So this is our final answer. Please, in order to get it easily, what you need to do is, before I solve, you can decide to cover this answer side, solve it yourself, and see if you get the same answer as I did. All right? The next question is 2 times 4 raised to power 6a is 4 raised to power 6a times 16 times, or 16a raised to power 3. Again, 2 times 4 raised to power 6a times 16a raised to power 3. Now, the first thing that will come into my mind, all these base, the figures or the numbers, the base, they seems to be different. So let me try and make them homogeneous or make them the same. So what I will do is simple. 2 raised to power 1 times 4 is the same thing as 2 raised to power 2. So it's 2 raised to power 2 raised to power 6. This is the 6. But this 4 is now 2 raised to power 2. Remember, we now have 2 power. And I have taught you in my part 2 of indices series, I told you that if you have 2 power, what you have to do is simply multiply them. All right, we'll come to that level. A times, now 16 is the same thing as 2 raised to power 4. 2 times 2 is 4, times 2 again, 2 times 2 is 4, times 2 again is 8, times 2 again is 16. So you have to multiply 2 4 times to get 16. So 16 is the same thing as 2 raised to power 4, a raised to power 3, just the way we have there. Once you have gotten this step, the question now becomes easy to solve. We now have 2 bases. We have base as 2. We also have another base as a. So let's solve the 2 parts of it first. Now we have 2 raised to power 1 times 2 raised to power 12. 2 times 6 is 12. A raised to power 1. Remember, if there's nothing here, I remember telling you that we have to add 1. There's an invisible 1 there. So it's a raised to power 1. Here is 2 raised to power 4, a raised to power 3. Let's solve the 2 parts of the base first. We have 2 here, 2 here, 2 here. So we'll pick 1, 2. Because it's multiplication, this is times, we'll have to add the powers. So I'll now have to add the powers. 1 plus 12 plus 4. That's 1 plus 12 plus 4. Now we are done with the first base. The second base is a. So I'll put my a here. What is the power of a here is 1. Power of a here is 3. So now I have 1 plus 3. This plus this is 17, 2 raised to power 17, and 1 plus 3 is actually a raised to power 4. So this is our answer. You can decide to use your calculator to get this figure and put there also. You can solve further. All right. So let's go to number 5. Let's start number 5. Number 5 is 10p raised to power 5 q r raised to power 3 divide 5p raised to power 3 and r. So how do you solve this question? I will just use a very simple way to solve it. I write this as the numerator and write this as the denominator. Then you can solve it. You can try to solve it straight anyway. So, but let's just do it this way. It's easier to solve this way. Now I have 10 times p raised to power 5 times q times r raised to power 3 is the same thing. If I multiply this, I'll have this. Now divide 5 times p raised to power 3 times r. Now, I can decide to use 5 here 1 and 5 here is 2. So we now have this 2 here. Now, this and this, they are the same thing, right? Remember, if it's division sign, what do? You subtract. So I'll pick 1p, then 5 minus 3. So you realize that I'm doing the same thing, just I decided to put this in a way such that you can easily understand it. Now, do we have any q? No. I'll just put the q down. We have arrow here. We have arrow here. So they are the same base. I'll pick one arrow. Because of the division sign, I'll put 3 minus. Remember, the minus is because of the division sign. 3 minus 1. Remember, there's an invisible 1 here. So I have pick one of the arrow, then 3 minus 1. After that, you just put 2 times this minus this is 2. P raised to power 2. Q. This minus this is what? 2. You now have 2p square q and arrow what? Square. If you multiply this, you have 2p square q and arrow square. So that's the answer. The next one is simple. You can see this is a very simple mathematics written on the board. Now, take a look at this. You have minus 3 bracket 3 square y raised to power 3 z everything raised to power what? 5. Remember, if a power is raised to another power, what you do is simple multiply. So I'll just expand it. I'll use this one to multiply all the powers inside. Now remember, since there is no number here, I'll put 1 here. I'll now use the 5 to multiply these two. That's 3 raised to power 2 times 5. The 5 to multiply these 3. Y raised to power 3 times 5. Now I'll now use the 5 to multiply this one. Z raised to power 1 times 5. Remember, this 3 minus 3 is still there. So if you do 2 times 5, you have 10. 3 times 5, you have 15. 1 times 5, you have this. The minus 3 is still there. So finally, I can now decide to involve the minus 3. Remember, minus 3 is actually raised to power 1. This is like a multiplication. So like a multiplication sign, I'm using minus 3 to multiply this. So times 3 raised to power 10 times y raised to power 15 times z raised to power 5. This and this, since it's also multiplication, I can pick one, minus 3, then add these two upper sides together, which will now give me 11. So this is our final answer. The next question is, I'll be solving about 10 or more questions. So just take your time to practice them. Always solve before I solve mine. You can copy the question, solve them, then you now look at the way I solve mine. You may even end up solving your own in a different way and getting the same answer. Okay, so t 10 bracket minus t square raised to power 3. Remember, once you have a power raised to another power, it's simple, you have to multiply. All over minus 5 t raised to power 8. Remember, I said you have to multiply, right? Which is 2 times 3. You copy it and you use 2 times 3. 2 times 3, what will you have? You have 6. So it's now minus t raised to power 6. Still take your 10 down. All over, I have not touched the denominator, so I'm still taking the denominator down. Now, once you have this, I can now use the 10 to multiply this, and you have this. Here, I can now use the minus sign, can cancel the minus sign here. 5 here, 1, and 5 here is what? 2. So I will now have 2 t raised to power 6 all over t raised to power 8. This is a simple thing. So because this and this, they are the same thing, I can decide to rewrite it this way. But I can just pick one. Then, because of this division sign, it will now be 6 minus 8. So, but I decided to rewrite it this way so that I will pick one. Then 6 minus 8 is the same thing. It's direct. It's what I've been doing since. So, 6 minus 8, you have minus 2. It's now t raised to power minus 2. Now, remember, anything, if you now just want to multiply this, you have this. Remember, anything raised to power minus of a power is 1 all over that same thing. It's also in the part of the law that I've taught in my previous video. So we now have 2 times 1 all over t raised to power 2. Remember, this 1 all over t raised to power 2 is because of this negative sign. If I just want to multiply this, I have 2. And if I use 2 times 1, we have 2. Then put your t down. You now have 2 all over t squared. This is our final answer. So let's solve number 8. Open bracket minus x raised to power 3, close bracket, times x raised to power 4 all over minus open bracket minus x raised to power 6, close bracket, open another bracket minus x raised minus x, then close bracket. You can see the question on the board. This is a very direct question. What do you need to do? I'll just open the first bracket, and what is there is what I put there. The second is still the same thing, and here, and in place of this place, I just put my multiplication sign there. Now, note that, as I've said earlier, multiplication sign is actually addition. You add the powers. So, remember, this is like minus 1. So, minus 1 times plus 1 here, you still have the minus. Then, I'll pick 1x. Then, I'll now add the powers. That's what we have here. all over. Now, here we have minus 1 times minus 1. In this denominator case, we will now have plus 1. Because if you use negative sign to multiply negative sign, you have a positive sign. So remember, there is also an invisible one here. So I will now have 6. I will now have 6 plus 1. And my answer for the numerator, that add this and this together, I now have minus x raised to the power 7. And for the denominator, I will now have 6 plus 1 is also 7. So x raised to the power 7. Now, this one, I can rewrite this as minus x raised to the power 7 divide x raised to the power 7. And we know that division is actually negative sign. So this negative sign times the positive sign here will still have negative sign. So we'll pick one x. 7 minus 7 is actually x raised to, remember, we'll have minus 1 here. We'll now have x raised to the power 0. Anything raised to the power 0 is 1. 1 times minus 1 is actually minus 1. So the next one is 64 raised to the power minus 1 over 3. Remember, if any value is raised to the power minus any power or any index, you will now have 1 all over that same value raised to the positive of that value. So we now have 1 all over 64 raised to the power 1 all over 3. Now remember, the denominator is actually is 3, so it's cube root. Why 64 is now raised to the power 1, but since it's one value, there's no need. So we now have 1 all over cube root of 64. Cube root of 64 is actually 4, so we now have 1 all over 4. Remember, how did I know that cube root of 64? You can use your calculator, or 4 times 4 is 16 times 4 again is actually 64. So you realize that cube root of 64 is actually 4. The next one is question number 10. Remember, as I said earlier in my video, you can always copy the question, solve it first, then check if you are getting the same value that I got. All right? So question number 10 is, we have 16 raised to the power minus 1 all over 1. 16 raised to the power minus 1 whole number 1 all over 4. Quickly convert this to improper fraction. So we now have 4 times 1 is 4, plus 1 is 5. We now have minus 5 all over 4. 16 raised to the power minus 5 all over 5. I just converted this to improper fraction. All right? So note that. All right? Now, after you getting this, remember, the numerator is the power, while the denominator is the root. All right? So, but because of this negative sign, I'll first put 1 all over this value. The negative sign will definitely disappear. So we'll now have 1 all over 16 raised to the power 5 over 4. As I said earlier, the numerator is the power, while the denominator is the root. So we'll now have 1 all over 4th root of 16 raised to the power 5. Now, 4th root of 16 is actually 2. Note that 2 times 2 is 4, times 2 is 8, times 2 again is 16. So 4th root of 16 is actually 2. So we now have 2 raised to the power 5. 1 all over 2 raised to the power 5. And 2 raised to the power 5 is actually 32. So we now have 1 all over 32. And the last question before I give you assignment is, this question be displayed on the board. It's a very easy question. Sometimes it looks complex, but it's so easy. It's because of the teaching that I'm using time to explain. You can solve this in 3 steps. All right? The first thing that you do is this. You know that this is a square root. So the square root simply means that everything here is raised to the power 1 all over 2. But before we do that, let's cancel out first. 2 into this is 16, and 2 into this is 81. So we now have 16 p raised to the power 6, y raised to the power 2, all over 81 p raised to the power 6, and z raised to the power 8. Remember, the only thing I did here is just to divide out so that we'll have reduce it a little bit. All right, so we have 16 here, we have 81 here. Now, I said everything here everything in this place is, we are looking for the square root of everything here. We can decide to raise each parameter or each value to 1 all over 2. It's the same thing as having the square root. So we now have 16 raised to the power minus 1 over 2 P raised to power 6 times 1 over 2. That's the power. So that's what we have here. So that's what we have here. We have 16 raised to power minus 1 over 2. X raised to power 4. Now, times 1 all over 2 is like raised to power 4, then raised to power minus, raised to power 1 over 2. You have y raised to power 2 times 1 all over 2. This is the power, this is like the square root. These are the square root. Because the denominator is actually 2. So we'll do the same thing for the denominator. It's 1 raised to power minus 1 s raised to power 1 over 2. P raised to power 6 times 1 over 2. And we'll do that for that. Now, after doing that, what do you need to do? Just cancel out. 2 will cancel out this. We now have x raised to power 2. These 2 will cancel this. So we now have y raised to power 1, which is the same thing as y. For this p raised to power 6, 2 will cancel out this. And we now have p raised to power 3. 2 will cancel 8. And we now have z raised to power 4. For this place, you can simply look for the square root of 16, which will give us 4. And look for the square root of 81, which will give us 9. Then copy this same thing down. That is your answer. There's no big deal. It's a very simple process. Now, take this as assignment. You can always solve it and screenshot your answer or take a picture of your answer, send it to the mail that is being displayed on the screen. Note that you have 6 questions. Just play with it. And if you do that, if it's not correct, I'll reply you. If it's not correct, I'll solve and snap and send the correct answer to you.